Have you ever bitten into a raw jalapeno? Or, if you're feeling adventurous, a ghost pepper? You know that sensation instantly. It starts as a tingle and rapidly expands into a blazing inferno that radiates across your palate. It feels exactly like you've just sipped boiling hot tea, doesn't it? Your eyes might water, your brow starts to sweat, and you reach for ice water. But here's the fascinating twist. There is no fire. There is no actual thermal energy. If we placed a sensitive thermometer on your tongue at the peak of a spicy meal, the temperature wouldn't budge a single degree. That sensation? It's a complete biological illusion. Let's dig a little deeper into this sensory magic trick. When you burn your tongue on hot pizza, you are physically damaging tissue with thermal energy. The heat transfers to your cells and cooks them slightly. But spicy food works entirely differently. You could eat the hottest pepper in the world, the Carolina Reaper, and while you might be in agonizing pain, your tongue isn't actually being burned in the physical sense. No blisters from heat, no charred cells. So if the temperature isn't rising, why does your brain scream fire? It turns out your mouth is the victim of a very sophisticated chemical prank pulled by a specific molecule. Meet the culprit, capsaicin. It's an oily chemical compound found in the white pithy membranes of peppers, not so much the seeds themselves, despite popular belief. Capsaicin is a shapeshifter of sorts. It has evolved to perfectly mimic a specific signal that your body takes very seriously. It's odorless and colorless, making it a stealthy operator. When you chew a chili, you release this oil, and it washes over your tongue. It's hunting for a specific target, a docking station on your nerve cells. It's not looking for taste buds that detect sweet or sour. It's looking for pain receptors. To understand the trick, we have to look at the lock that capsaicin picks. Embedded in the nerve endings of your tongue and skin are proteins called TRPV1 receptors. Think of these as tiny biological thermometers. Normally, their job is to stay asleep until the temperature rises above roughly 109 degrees Fahrenheit, the point where heat becomes dangerous and could cause physical harm. When actual heat hits that threshold, the TRPV1 channel opens up, allowing calcium ions to flood the nerve cell. This electrical shift sends a frantic message to the brain. Warning, it's hot, pull away. Here is where the chemistry gets really clever. The capsaicin molecule happens to have the exact geometric shape required to fit into the TRPV1 receptor. It's like a skeleton key. When capsaicin binds to these receptors, it forces the ion channel to open, even at room temperature. It lowers the activation threshold of the receptor. Suddenly, your normal body temperature of 98.6 degrees feels like scalding lava to that specific nerve. The receptor is tricked into thinking the temperature has skyrocketed, even though nothing has changed. It sends the exact same electrical signal to the brain as if you drunk boiling water. So the signal shoots up your trigeminal nerve and arrives at the brain. Your brain is essentially sitting in a dark room, relying entirely on these incoming phone calls from your nerves. It receives the signal from the TRPV1 receptor and interprets it the only way it knows how: thermal burn. The brain doesn't know it's a chemical trick. It only knows the code for hot. It's a classic case of crossed wires, or rather, a hacked signal. This is why spicy food is often described as hot in almost every language. Our subjective experience is indistinguishable from thermal heat, even though the cause is purely chemical. Because your brain is convinced you are literally overheating, it initiates a full-blown cooling protocol. This is why you get the physical symptoms of eating spicy food. Your brain thinks, we need to cool down the system immediately. It dilates your blood vessels, causing you to flush red. It triggers your sweat glands to release moisture to promote evaporative cooling. It makes your nose run and your eyes water to flush out the perceived irritant. It's a massive, coordinated biological fire drill for a fire that doesn't exist. You are sweating to cool down a tongue that isn't actually hot. You might wonder, why on earth would a plant produce a chemical weapon like this? It wasn't for our culinary pleasure. It was evolutionary warfare. Capsaicin is a deterrent. In the wild, pepper plants want to avoid being eaten by mammals, like mice or humans, because our digestive systems destroy their seeds. We grind them up with our molars. So the plant evolved a chemical defense to say, "Stay away, this hurts." It's a brilliant strategy to repel mammals. The irony, of course, is that humans are the only mammals weird enough to enjoy the pain, completely defeating the plant strategy. Nature is never one-sided, though. While peppers developed capsaicin to fight off mammals, they needed someone to spread their seeds. Enter the birds. Birds don't have teeth. They swallow seeds whole, which pass through their digestive tract intact and are dispersed effectively. Here is the kicker. Bird TRPV1 receptors are shaped differently than ours. Capsaicin does not bind to them. A pigeon can eat the hottest ghost pepper like it's a sweet grape and feel absolutely nothing. The plant evolved a specific chemical key that locks out mammals but leaves the door wide open for its avian couriers. This brings us to the human behavior. Why do we do it? Why do we voluntarily induce a fight-or-flight response over dinner? Psychologists call this benign masochism. It's the same reason we ride roller coasters or watch sad movies. We know the threat isn't real. We know our tongue isn't actually dissolving, despite what the nerves say. This safety net allows us to enjoy the thrill of the physiological rush without the danger. We are essentially hacking our own nervous system for entertainment, turning a pain signal into a source of excitement and culinary complexity. There is also a chemical reward for enduring the burn. When your brain receives those intense pain signals, it tries to help you out. It releases endorphins, the body's natural painkillers, and dopamine, the happiness chemical. This is the runner's high of the culinary world. After the initial shock of the heat subsides, many chili heads report a feeling of euphoria or a floaty sense of well-being. This chemical cocktail is potent. It's what keeps people coming back for spicier and spicier sauces. They aren't just chasing the flavor, they are chasing that neurochemical rush that follows the pain. If you eat spicy food regularly, you've probably noticed you can handle more heat than your friends. This isn't just mental toughness, it's biological desensitization. Capsaicin causes your nerve endings to release a neurotransmitter called substance P, which transmits pain signals. If you eat enough spice often enough, you essentially deplete your supply of substance P. The nerves literally run out of the pain juice needed to send the message. Eventually, the nerve endings can even temporarily retract or die back. You aren't just getting used to the taste, you are physically silencing the messenger. Now, let's talk about the antidote. You've taken a bite that's too hot. Do you reach for water or milk? Chemistry has the answer. Capsaicin is a hydrophobic, non-polar molecule. This means it repels water. Think of it like baking grease. If you drink water, you are just spreading the grease around your mouth without dissolving it. It doesn't wash the capsaicin off the receptors. Alcohol is also mostly water, so that beer won't help much either. You need a solvent that can dissolve a non-polar oil. You need fat, or something chemically similar to detergent. This is why milk is the ultimate fire extinguisher for your mouth. Milk contains a protein called casein. Casein is lipophilic, meaning it loves fat. It surrounds the capsaicin molecules, binds to them, and scrubs them off your nerve receptors, washing them away like soap cleans grease off a pan. Full-fat milk, yogurt, or ice cream works best because the fats help dissolve the oil while the casein does the heavy lifting. Sugary drinks help a little because sugar can distract the brain, but for a true chemical cleanse, dairy is the only way to break the bond.